To remember this reaction, you can keep this structure in front of your eye. You have to imagine this structure. Now this structure is, because this is something characteristic structure, so you can imagine this structure, the middle C double bond O, and then this bond, two double bonds, and this side phenyl part, phenyl part. So if you see this structure, how this structure is formed, you can easily understand that this is C double bond O, here is carbon, carbon, so it can be CH3, CH3. We can break this structure like this, right? So this is called acetone. And this part, this is phenyl, C double bond O and H. So this is benzaldehyde part. And this is also benzaldehyde. So if you want to prepare this product, what you're requiring is that the middle carbonyl ketone, which is acetone, and two aldehyde molecules, which is benzaldehyde. So this is the reaction where aromatic these aldehydes reacts with aldehyde or ketone. Here we have taken example of ketone to form this compound, which is called Claisen Schmidt condensation. So what is happening in this reaction? If you see, in this reaction, we're requiring sodium hydroxide, strong base, and we required some heating, and this is solvent. In this reaction, the water molecule is byproduct. Two water molecules are formed, and this is called condensation reaction where the water molecule is a byproduct. So this is Claisen-Schmidt condensation. So we are going to see actually how this reaction takes place. So first we have to consider this ketone part. This is acetone. Because we are using strong base, so this OH minus. So what it will be doing is that it will be taking one of the hydrogen from this methyl part. So there are two methyl. You consider any one. So this is say CH3. So OH minus will abstract. It will take H plus from this methyl. So because H plus is with this OH minus, so water will form. And because hydrogen gone from this methyl without electron, so electrons are on the carbon, so it will acquire negative charge. If you see this carbon, it is connected to this carbonyl carbon, so electron from this carbonyl carbon can redistribute like this. Electron can go on oxygen easily, and this negatively charged carbon now can form bond with this electron deficient carbon, so double bond. So this is also reversible, this is also reversible. Byproduct form is water. Now this part, is connecting with this aromatic part. How? You see, now this carbon's valence is satisfied for, but oxygen cannot keep the electron forever, so it is redistributing its electron now already 4, so this pi bond is breaking. Electrons now with the carbon negatively charged, and as we know that carbonyl carbons are electron deficient, so this negative will attack on this electron deficient carbon. Simultaneously this pi bond will be broken, electron will shift on the oxygen. So what is happening is that here double bond is forming, this bond is breaking, this carbon is connecting to this carbon, oxygen is acquiring negative charge. So it is written like this CH3, C, now here it's double bond, then CH2 as it is. Now this is CO minus, electrons are shifted on oxygen, and hydrogen as it is. Then in this system, protic solvents are used. Water is used. So H plus is coming from this protic solvent, water. So H plus will be taken by this O minus. So obviously it will form OH, right? So if you see this structure and this structure, which is reversible, only difference is that here O minus, here is OH. And the next part OH minus. Now this OH minus, we are using base, right? This OH minus will abstract one of the hydrogen from this carbon. There are two hydrogens. If you see here, initially we said same, hydrogen abstract negative charge, right? Same here also, negative charge. And in this reaction, if you see here, negative charge is formed. This carbon electron deficient, so double bond will form here. These electrons are shared with this carbon. Already 4 bonds, so pi bond is breaking, electron are shifting on oxygen, so negative, right? So what happened here? CS3, this CS3, CO minus, and here is CH double bond. Now this structure, again redistribution of electrons, right? So it is redistributed. This structure can convert back to this structure again, or it can be, next option is like this, that this bond will shift this side and this OH will leave as OH minus. Okay, so what is happening here? CS3, C double bond O, CH double bond, and then CH and this phenyl part. If you see this structure, you can understand this structure is half part of this C double bond O. So this is C double bond O, CH, then the CH, then double bond, here is double bond, then phenyl. So this is phenyl. So half portion is formed. Same thing will be repeat again, but this time this CS3 will be involved because this is involved in the reaction and this part is completed. Same happen this side also, from this CS3, same reaction will take place, and this part will also convert to this. So this is called Claisen-Schmidt condensation reaction. In this reaction we have to use strong base, and in this reaction water is byproduct.